Okay, this video is for the Quadratics module, and in this video we'll be looking at section Quad G. In this section we're looking at quadratics and equation solving. Now, a quadratic equation has a standard form ax squared plus bx plus c equals 0, where a, b, c can be positive or negative. Now, the standard form of a quadratic equation has a quadratic expression equal to 0. Now, one method of solving quadratic equations is by factorising. And what I mean by solving is if we have ax squared plus bx plus c equals 0, we want to know what values of x make ax squared plus bx plus c equals 0. Okay, now this method uses the fact that if I have a times b equals 0, then either a has to be 0 or b is 0, because 0 times b is 0 and a times 0 is 0. Hence, factorising ax squared plus bx plus c equals 0 into its brackets, so just say I have those there, jk plus x times, jx plus k times mx plus n, where j, k, m and n are constants, then either the first bracket, jx plus k, has to be equal to 0, or the second bracket, mx plus n, has to be 0. Also remember to take out common factors first. So let's look at some examples. The first one, I have x squared plus 2x minus 3 equals 0. Now we need to factorise that. Whichever method you want to use, go for it. You'll end up with x plus 3, x minus 1 equals 0. So either splitting terms, cross method, box method, use whichever. Now for this to be true, either x plus 3 has to be 0 or x minus 1 has to be 0. So from there, and isolating the unknown, take 3 from both sides, we have x is negative 3, add 1 to both sides, x is 1. So there are our two solutions. The next one, x squared minus 3x minus 10 equals 0. First we factorise it. Again, whichever method you use, you end up with x minus 5x plus 2 equals 0. Okay, so from there, x minus 5 has to be 0, or x plus 2 has to be 0. So x is 5, or x is negative 2. Okay, next one, 6a squared plus 17a plus 5 factorises to 2a plus 5, 3a plus 1 equals 0. Remember to show the method that you're using to factorise as well. I'm just trying to save some time. So 2a plus 5 has to equal 0, or 3a plus 1 equals 0. 2a equals negative 5, a is negative 5 over 2, which is also negative 2.5. Okay, 3a is negative 1, a is negative 1/3. So there are my two solutions. 6x squared minus 9x equals 0. Common factor is 3x, so bring it out the front. And we have 2 times 3x is 6x, so we need 2x. 2x times 3x is 6x squared, minus, because I have minus term, and I want 3. 3 times 3x is 9x, so that has to be 0. So from there, 3x has to be 0, or 2x minus 3 has to be 0. So x is 0, 2x equals 3, x is 3 over 2, or 1.5. Okay, so that's how you solve. Now it may be necessary to rearrange a given equation. Rearrange a given equation into ax squared plus bx plus c before you can factorise. So you need everything on one side. So here I have x squared plus 2x equals 3. I need to get that 3 onto the other side, so I'm going to take 3 from both sides. And I end up with x squared plus 2x minus 3 equals 0. When I factorise it, I have x plus 3 all times by x minus 1 is 0. So from there, x plus 3 equals 0, x equals negative 3, or x minus 1 equals 0, x equals 1. Okay, next one. Again, I need everything on one side. The x squared term's already positive, so I'm going to take the other things over to meet it. So I've got x squared, take 3x, take 10, equals 0. Factorising that, I end up with x minus 5, x plus 2 equals 0. So from that, x minus 5 has to be 0, or x plus 2 has to be 0. So x equals 5, x equals negative 2. Okay? Now, the special case factorizations result in specific solutions. There will be only one solution for quadratic equations containing squares of sums or differences, and the difference of perfect squares will result in a positive and negative value of the same number. So what I mean by that is if I have x squared minus 6x plus 9 equals 0, that is a square of difference. So I can rewrite that as x squared take 2 times 3 times x plus 3 squared equals 0. So that becomes x minus 3 all squared is 0. So I have only one solution, x minus 3 equals 0. So x has to be 3. Okay, in this one I have a common factor of 2, so bring it out first. Now that is a square of sum. Now if you don't notice that, you can use your other methods of factorization, so you can still use the splitting terms, the box method or the cross method. You'll end up with the same answer, so don't stress if you don't notice it. But if you do, you've got 2x squared plus 2 times 5 times x plus 5 squared equals 0. So that becomes 2 lots of x plus 5 all squared equals 0. So x plus 5 has to be 0, x equals negative 5. Okay, last one, x squared equals 144, so get everything on one side. That now is a difference of perfect squares, and it's x plus 12, x minus 12 equals 0. So from there, x equals negative 12. Sorry, I should do that in full. X plus 12 equals 0, so x is negative 12. X minus 12 equals 0, so x is 12. So x can be plus or minus 12. Okay. What now? You need to practice. So complete exercise quad G1 from the textbook. Remember to ask for help if you need it.